So what we're going to do now is we're going to solve quadratic equations by using the completing the square method. Now recall that we used completing the square, or we were introduced to it when we were actually factorizing quadratic equations and expressions. So here the learning objective is going to be able to solve quadratic equations using a range of strategies, focusing exclusively on completing the square for this video. So what we know is that we would generally use the completing the square method if our solutions are deemed to be numbers that are not rational. So let's just quickly review what the completing the square method is. So before we do that, I'm going to write our general form for a quadratic equation, which will be y equals ax squared plus bx plus c. So the first step says to identify the coefficient of the x term, which is represented by b, halve it, and then square the result. The second step says to add the answer from step 1 into the expression and make sure that we place it after the x term. To ensure that the equation doesn't change from its original form, we need to subtract the same amount that we added. Step 3, we need to factorize the first 3 terms to produce a perfect square. And then step 4, we need to express the answer as a difference of 2 squares. So let's take a look at the worked example here, or the example that we're going to work through. It's asking us to find the solution to the equation 0 equals x squared plus 2x minus 4. And what we need to do here is to leave our answer in exact form. So let's follow through the steps and then go on and actually solve it. So step 1 says to identify the coefficient of the x term, and that coefficient is 2. So what we're going to do now is halve it and then square it. So that's going to give us an answer of 1. So now we're going to add that into the expression, or the given equation. So that'll be x squared plus 2x plus 1 minus 4. Now what we've done here with the plus 1 and minus 1 is made sure that we haven't actually changed the question itself. We've just changed how it looks. So now I'm going to go ahead and factorize the first 3 terms. So doing that, I'm going to end up with x plus 1 all squared, simplifying the negative 1 minus 4 to give me minus 5. So what we've got now is a perfect square, which is x plus 1 all squared. And now I'm going to express this as a difference of 2 squares. Now doing that, I'm going to do the following. So x plus 1 minus the square root of 5, and then x plus 1 plus the square root of 5. I'm going to make this equal to 0 because that's what the original equation tells us. Now we're going to add the extra element, which is to solve it. So we're going to solve this using null factor law. So I'm going to do x plus 1 minus the square root of 5 to equal 0. So that will be x is equal to root 5 minus 1. And my second solution, which is x plus 1 plus square root of 5 equals 0. Solving that for x, I'm going to have negative root 5 minus 1. And my 2 solutions for the equation x squared plus 2x minus 4 when it equals 0 is when x is equal to root 5 minus 1, and when x is equal to negative root 5 minus 1. And what we've done here is we've used the technique of completing the square to help us solve our quadratic equation.